In this video, we'll take a look at how to use the TI series calculator to find critical values for your Z and then also to calculate a confidence interval. Please read section 7.2. This video only concerns using a calculator to help make our confidence intervals go a little quicker. All right, as you read through, what we're trying to do is to find an estimate of a population proportion based on a sample. So the most common confidence levels that we look at are 90%, 95, and 99. So how do we find those? What is a critical value and how do we find it on the calculator? A critical value is the number on the borderline separating sample statistics that are likely to occur from those that are unlikely. The number Z with an alpha over 2 is a critical value that's a Z-score with the property that it separates an area of alpha over 2 in the right tail of the standard normal. All right, a picture probably is worth all of those words. So if you take a look at a normal curve and you want to find critical values for a confidence level of 95%, that means that we want 95% of the area to be in the middle and that 5% of the area to be split among the two tails. So when it has an alpha over 2, that means that we want to find the Z-score, the one on the right that goes with a 0.025 area there, because that area plus this area is 5% and there's 95 left in the middle. So we can use the inverse normal on the calculator to do this. So just a reminder of that, we've done this in a previous. It's in the distributions. We hit second variables. Option number 3 is inverse normal. And what we do on here is type in the area, that 0.975, the area to the left of the Z-score we're interested in getting, comma, mean, which in this case is 0, standard deviation of 1, and that will tell us the Z-score that goes right here. That means that the leftmost area is 0.975 and the area on the right is 0.025. So a critical value for a 95% confidence interval is 1.96. All right, then what do we need that for? There's an example in your textbook on page 323. Well, the chapter problem's on 323. The solution to this problem by hand is on 331. It says that in the chapter problem, the Pew Research Center poll of 1,007 randomly selected U.S. adults showed that 85% of the respondents know what Twitter is. So the question is, does this mean that 85% of the population of all adults know what Twitter is? There's many, many more adults than 1,007. So probably not. But what we do is we use the information from the sample to make an estimate of the true proportion of the population who know what Twitter is. And what we do when we construct a 95% confidence interval, we'll interpret that at the end. So to do this by hand, read the example on page 331. This will help you with the understanding of what we're finding. You first verify requirements in the preceding box are satisfied. That means verify that, first of all, you have a random sample. You have to verify, secondly, that the conditions for a binomial distribution are satisfied. Those are the 4 conditions listed back in chapter 5. And you have to verify that you have at least 5 successes and 5 failures. Then step 2, use technology or the table to find your critical Z value. We'll use our calculators. 3, you find a margin of error. And use this formula. 4, using the value of your margin of error, you actually estimate, you add that to, add and subtract that value from your sample proportion, and then that will give you an estimate of the population proportion. So as the solution to that, if you look on the textbook, the margin of error for this case was 0.0220545. To construct the confidence interval, we take our sample proportion 0.85 and add that value. We get 0.872. We take the sample proportion and subtract our margin of error. We get 0.828. And what this means is the interpretation, based on the sample of 1,007 people, the true population proportion of people who know what Twitter is can be estimated at between 82.8% and 87.2% at the 95% confidence level. So when we have our sample and try to make a prediction about the population based on the sample, our answer is an interval. In statistics, what this means, if we keep taking samples of 1,007 people over and over and over again from the population and record the sample proportion, 95% of the time our proportion would be between those two numbers. Okay, so how do we use the calculator to do this? All right, well, the calculator will help you find the confidence interval, but it won't give you the margin of error. So there may be some questions where you have to use this formula right here. So the margin of error is your z-score, the 1.96, times p hat, in this case would be 0.85, times q hat, which is 0.15, divided by the sample size, 1,007. So the calculator, what we do is this test is programmed in the calculator. So what we do is we go to the stat key, arrow over to get to tests, arrow down until you find option A, which is a 1 prop z interval. Hit enter and type in what we know. X is the actual number of successes. In this case it would be the number of people that said yes, that they knew what Twitter was. So you have to take the 0.85 times 1,007. If that's not a whole number, round it. So that rounds up to 856 people knew what Twitter was out of 1,007 in the sample. Type in your confidence level. I think you can put just 95 or a 0.95. I think your calculator doesn't mind either way. Go down to calculate, click enter. And what your calculator will do is it'll tell you p hat, which is 0.85, and it will give you the sample. It'll actually give you the values, that 0.828, 0.872. So your calculator doesn't do any of the middle work, it just tells you the confidence interval. And the interpretation is the same. We can estimate the population proportion of people who know what Twitter is somewhere between 82.8% and 87.2%.